Hi, I'm Matt Eland, and welcome to .NET Fundamentals. Today I'm going to be talking to you about arrays in C# and .NET. This is a very introductory lesson. I don't assume that you have a lot of experience at all with .NET and C#. However, to get the most out of this lesson, you should already be familiar with variable types and just the basics of C# and .NET, the common language runtime, things like that. However, keep watching. Even if you don't know these things, you're probably going to get some value out of this. This is a very beginner-oriented lesson. Alright, so before I can really talk to you about arrays, I should probably illustrate what problems arrays exist to solve. And I'm going to do that in a little bit of a fun way by talking about pizza, because most people like some form of pizza or another. So let's pretend that I, despite my friends and family's encouragement, open a pizza store. I really shouldn't because I'm a horrible cook, but let's say I do it anyway. And I'm going to start very simple with just one pizza. So in my little pizza menu application, I'm going to just define, hey, what pizza do I have? Oh, it's a pepperoni. Okay, so string pizza equals pepperoni. Somebody comes in, what's my pizza? Oh, I'm going to read from pizza. Yeah, it's a pepperoni. Do you want it? Sure. Yeah, okay, fine. Nobody's going to do business this way, but bear with me, right? So let's say that enough people survive my cooking and pay me for it, that I'm still in business in a week. And they come back, and now I have a couple more pizzas. So, okay, so pizza 1, pizza 2, pizza 3. You can maybe start to see where this is going. But people say, hey, what do you want? Well, okay, well, you can have pizza 1, pizza 2, or pizza 3. Which of these do you want? Like, okay. And now it's a little bit more of a legitimate pizza restaurant, so it starts to catch on. And then the next week, I open up, and I decide, you know what? People are complaining that I don't have enough flavors. Let's add some more. And so now all of a sudden, I got 42 flavors of pizza, and my code is an unmaintainable mess because I have so much duplication and so much similar code. So what I really need is a way of interacting with similar things in a more structured and systemized way. And so that is really the problem that arrays exist to solve. So let's talk a little bit more specifically about what arrays are and how they work. So first of all, in .NET, an array must have a fixed number of items. And what I mean by that is that when you declare an array, you have to know the maximum number of items in advance that are going to be in it. Because when you declare it, it will create default instances of each item. In this case, I have an array of 5 pizzas, and each one of those is an element. Make sense? So secondly, each item in the array must be of the same data type. So I could have 5 pizzas, but I can't have 3 pizzas, a squirrel, and a bowling ball all in the same array. You're going to get a compiler error if you try to do something like that. It just doesn't work. But what you can do is you can have an array of 5 strings. And remember, null is a valid string. I can have an array of 5 integers, so the number of slices in a pizza, for example. Most of our examples today are going to be around strings just because it's a little clearer, but keep in mind that you can have integer arrays, date time arrays, things like that. You can also get very, very basic and just say, hey, I've got an array of Boolean values, so true and false. So, hey, does my pizza have onions? And so I know, hey, stay away from pizza number 4 because I don't like onions very much. So each arrays have a fixed number of items, and each item has to be the same type. They don't have to be the same value, but they have to be the same basic data type. Make sense? Cool. So the key advantage that arrays get you is they're very quick at inserting and setting and reading values. So here I'm setting array index 2, or pizza index 2 is going to be chicken bacon ranch, which is a wonderful pizza. I recommend you try it if you like that kind of thing. And it just very quickly sets the value in that particular array, given a string array, for example, here. And you may think that this is a bad example because that arrow is pointing to the 3rd pizza box. Well, this is actually correct, and the reason why this is correct is because in development land, arrays start at index 0. And so 0 is going to be your first one, 1 is going to be your second one, second's going to be your third one. And you may start screaming here and say, why did you do this? This makes everything complicated, and this is going to lead to errors. And yes, it does, but there's a very good reason we did it, and it's not because developers are trolls, though many of us are, including myself. Sorry. The reason we did this is because arrays are reference types that point to a grouping of memory inside of your computer. And so when you tell .NET, hey, I need an array with 5 elements and each element is a string, it's going to say, okay, well, how big is a string? Okay, well, I need 5 of them. Okay, so this is how much I need in memory for this array. And it's going to find a continuous block of memory that it's going to allocate to your array. Make sense? The reason why this is related to the index starting at 0 thing is because when we have a statement that looks like this, pizza's index 2 equals chicken bacon ranch, what it's really doing, it's starting at the left of that array, and it's making 2 hops to the right to get at what you want. So when you look at that index number, that's the number of hops to make from the left of the array. So pizza index 2 is going to be your third pizza box. Pizza index 0 is going to be your first, etc. This sort of hop mechanic that we're talking about here, this is what allows arrays to be very fast, because the .NET can quickly compute exactly where in memory an individual index is going to be. And so things are going to be extremely quick when we're working with arrays. All right, so now that we talked about some of the nitty-gritty, let's talk about some real-world examples of arrays. So obviously satellite arrays are going to be a key example because they literally have the word array in them, right? So here, imagine Jodie Foster in Contact. She's typing into her SETI terminal to control one of her satellites. And so she might go, satellite 2, I want you to adjust your inclination 2 degrees up. Who knows, right? But the point is, arrays allow you to control similar things in very similar ways. So you can have a program that works with an array with a specific index instead of, hey, satellite 2, go up 2 degrees. A little bit more efficient code, a little bit easier to spot mistakes as well. So this factors into our quality discussion as well. Let's talk about some other examples. Lockers are a good one. So we can say, hey, locker 4, who does this belong to? Or I'm going to assign locker 6 to Sue, or whomever you want, right? So you can quickly read from a specific index, and you can specifically set a value to that specific index. In this case, it might be, an assignment of who owns the locker, the name of the person who owns the locker, for example. Solar panels, well, you can look at an array and say, like, hey, how many watts am I getting off of panel 1, for example. So very similar things. You can start to read values from them. Servers are a very good one. So, hey, I want you to restart everything between servers 2 and 5, or which of my servers have the highest degree of CPU utilization, things like that, right? So arrays let us manage very similar things, and you can start to see some real-world applications for these things. Let's talk about seating. So you go to a movie theater or a sports arena, and you're going to have an assigned seat number generally. Airplanes too. So seats are a good one where you have like an index that's kind of assigned to things. Now this is maybe a little bit trickier of an example because this is an example of where we would have maybe a two-dimensional array. So you'd have the row and you'd have the column. We're not going to be talking about two-dimensional arrays today. We're going to be keeping this very simple and isolated to one-dimensional arrays. But just keep in mind that anything that you have a very similar type of thing, and you might have a lot of them, it's good to have an array or potentially a more advanced collection like a list or a dictionary or something like that. We're not going to be talking about collections today either, but they are built upon arrays. So it's important to understand these basic things. While we're talking about seating, let's talk about restaurants. If anyone's ever worked in a restaurant before, they know that you have table numbers. And those tables don't have to be exactly near each other. So table 10 doesn't have to be near table 11. You just use that index of the table to refer to very similar things. So Bob might be serving tables 2 through 5, for example. Or table 8 needs a new rolls. Who knows, right? Just a way of referring to very similar things in code. Sports scores. So here we have a baseball score, and you can look at this as maybe 2 arrays or a 2-dimensional array. You can say like, hey, how many points did Boston get in inning 2? And you can look at this and say like, hey, okay, they got 5 points. So this is an example of where an array is useful for getting statistics for a specific point in time, for example, in an inning. Now, you might look at this and you might spot a problem with this. Anyone think of any reason why a baseball score might not be the best use of an array? If you're blanking on that, how many innings does baseball typically have? It typically has 9, but it can go into extra innings. And because we can't resize an array is actually a bad place to store a baseball score, for example, because you can't resize them. But I think looking at these numbers, I think maybe it's helpful to see some of the applications that an array could have if you had a baseball game that was fixed at 9 innings or 10 innings only, which would be interesting. All right, so let's get back into the code. So how do we use an array if we want to work with an array? So here I'm declaring a new array. I'm saying string bracket bracket, and when you see bracket bracket like that, that's referring to an array. So you see open bracket, close bracket, always think that that's an array. Okay? So string bracket bracket pizzas, I'm declaring a string array variable named pizzas. Okay? Equals new string bracket 3 close bracket. Okay, so here I'm saying I'm going to allocate a new string array, and that string array is going to have 3 elements in it. And so these 3 boxes here, this is what it looks like after I've declared my array. Let's look at this a little bit more carefully here. So string and string, these two have to match. These are the types that are stored in the array. So this could be a bool array, this could be a date time array, this could be a custom object array, which we'll talk about objects later on in future lessons potentially. And this 3 here, that refers to the size of the array. So remember, we have a fixed size of each array, and this is where we tell .NET how big that array needs to be. So note that on the left, when we're declaring an array variable, we don't give it the capacity, but on the right, where we actually allocate that array, that's where we do tell .NET how big that array is going to be. When you do declare an array, each element in that array gets the default value for the type that you are assigning. So in this case, we're declaring a string array. The default value for a string is null. And so .NET's going to give us 3 null values in our array. Indexes 0, 1, and 2. Make sense? Cool. So let's talk about grabbing values from there. So let's say we have an array with pepperoni, chicken bacon ranch, and then the fancy arugula pizza, which I and nobody else seems to like. Here we're saying, hey, go to the pizza array, and I want the value at index 2. So the .NET runtime says, okay, I'm going to go to the start of that array, and then I'm going to go 1 hop to the right and 2 hops to the right. I'm going to grab the Mad Evelyn special value out of that, and then I'm going to replace it up here. So favorite pizza equals, and it's just going to assign the value that's stored in that in that second item, or that third item in the array. And then you'll wind up with favorite pizza equals arugula, prosciutto, lemon vinaigrette. Fantastic pizza, by the way, I love it. All right, setting pizzas, very similar. So here we're declaring the same type of an array, and this is really how we initialize this array we just looked at. So here we're saying pizzas index 0 is going to be pepperoni. Pizzas index 1 is going to be chicken bacon ranch. Pizzas index 2 is going to be arugula, prosciutto, and lemon vinaigrette. And again, we're doing 0 hops, 1 hop, and 2 hops, just to determine which bucket or which element in that array is going to store that value. So this is just like we're assigning to a normal variable, only the variable is really like a sub-address on that. So it's just which element in that array we're looking at. What if I try to do something weird? What if I try to set something beyond the size of my array? So here I have a string array with 3 elements, and I'm trying to set the 42nd index in this array to old socks, dried peaches, and gummy bears. I don't know who would order this pizza, but let's say somebody wanted to. Stop for a moment and think about what happens. Either this array is going to grow, or something bad is going to happen. In what we've been talking about with hops, we're going to go 1 hop from the left, 2 hops from the left, and now we're going to try to go a 3rd hop, right? And remember that arrays are just allocated somewhere in memory, we don't know where, And we don't know what's to the right of this. It could be your operating system. It could be your accounting system's secure data that you don't ever want to write to or read from. So this is a massive security issue. This is a massive operating system stability issue, because you try to write to Windows, for example, you might crash the thing. And so .NET says, hey, I'm not going to let you do that. You try to do this, I'm going to throw an exception. And specifically, it throws an index out of range exception telling you that you tried to access memory outside of the array, which, as I mentioned a second ago, is a very dangerous operation. So since .NET is a managed language, it manages its memory for you, and it says, like, you cannot do this. What this thing you're trying to do, like, this is dangerous. I'm just going to throw an exception. And this might annoy you as a developer, but this is stopping you from doing something potentially disastrous to your machine. So you're going to expect index out of range exceptions if you try to access anything beyond the capacity of the array or anything before the initial. So if you try to give it a -1 index for some reason, you're going to get an exception. Make sense? All right. So let's review and look at some practice examples here. So if we declare an array of pizzas, 5 pizzas long, and we set pizza index 1 to veggie lovers, what do we expect the rightmost box to be? What do we expect the leftmost box to be? Which box should have veggie lovers? What's going to be in everything else? Well, everything's going to be null except for that second pizza there, which is going to be getting the veggie lovers, because we're going 1 hop from the left and setting veggie lovers, and everything else defaulted to the default value for a string, which is null. Cool. All right. So here we're defining a string array of 3, and we're giving it a cheese, pepperoni, and sausage pizzas. Pretty simple. Then we're declaring a new string array named menu. This is a variable, a string array variable named menu, and we're setting it to the pizzas array. This is interesting. We haven't talked about this before. Next, we're setting index 0 on the menu array to be equal to meat lovers. My question to you here is, what do you suppose the value of the 0th index, or the 0th element, or index 0 on pizzas is? So pizzas index 0, is that going to be cheese, or is that going to be meat lovers? Well, let's take a look. What I'm really asking you here is, does this menu array point to the same array as pizzas, or does it point to a different one? And think back to what I said, because I said that arrays are reference types. And that means that they reference a specific chunk in memory. And so here we're setting pizza, or string array menu is equal to pizzas. Now pizzas is a reference to a specific point in memory. So now menu is pointing to that exact same chunk in memory. So really they're effectively using the same array. So let's watch what happens. So here we've established that these are both the same array, and now we're saying menu 0 is meat lovers. That means that pizza 0 is also the meat lovers pizza, because they both refer to the same portion in memory. You can use either one of them to interact with that data, but they're really just 2 separate instances of the same address. Make sense? Okay, so what's wrong with this? It's not that we're assigning veggie lovers, as much as I don't particularly like the onions and peppers on that pizza. The problem with this is that we are going 5 hops to the right in something that we can only go 4 hops maximum, so we're going to get our index out of range exception again. All right, so here we're defining a new array of 5 pizzas. We're setting the first element to be cheese, and now we're setting the element at index 4 to be the value at index 0 of that same array. Next, we're setting index 1 to be supreme, and we're setting index 0 to be taco pizza. So my question is, what's in box 0? What's in element 0 of this array? And what's in element 4? Let's take a look. So we start out with an empty array with default values of null and everything. Next we set cheese into that first element. Next we set the 4th element equal to the value in index 0. In this case, we're grabbing the value of that string, which is cheese, and we're setting it into that fourth one. We're not taking the same memory address of it. We're just saying, hey, I want you to use this value. The strings are kind of complicated in .NET because there's some optimizations under the covers. But when you're working with a string, remember it behaves like a value type. So you're passing around a value. Even if you change something else, you still have that value in memory and you can work with it effectively. The optimizations I'm talking about are all really just for memory management, and you don't necessarily need to think about them too much. So here, saying pizza index 4 is equal to the value in pizza index 0. So setting it to cheese. Next, setting index 1 to supreme. And finally, we're setting the index 0 to taco pizza. Because this is a value, the value we have earlier in index 4, is still remaining as cheese. I know that gets a little complicated, but just remember, changing cheese in one doesn't change it in the other one because these are value types, effectively. So, when would you use an array? I would use an array when I have many similar items, when I know the type of each item, and it's the same, and I know how many items are going to be in that array from the very beginning. And the way that arrays shine is when you want to get and set items by a specific index. Cool? So many similar items, same type, you know how many you have, and you expect some performance improvements by getting and setting items by a specific index. All right, well, I'm Matt Eland. I write frequently on software at killalldefects.com. You can follow me on Twitter at integerman, and if you like this, please be sure to like and subscribe and all that fun stuff. Thank you.